concurrent properties related to triangle. So result to concurrency of the altitude of a triangle. So in a triangle, altitude of a triangle are concurrent. Concurrent means passes through a single point. Point of intersection of these three lines, three altitude is 1, only 1. So consider the triangle AX1Y1, BX2Y2 and CX3Y3, right? Let AD, BE and CF be respectively altitude drawn from the vertices ABC. So AD meets the side BC at D and AD perpendicular to BC, because the altitude of a triangle perpendicular to the opposite side, right? So the altitude from the point A, right, which is perpendicular to the opposite side, that is opposite side BC, right? So AD is the altitude which is perpendicular to BC, right, this one. Similarly, BE is a perpendicular line from B to CA, that is the altitude, and CF is a perpendicular line from C to AB meets at F, right? So we know slope point form of a straight line passes through x1 y1 is y minus y1 equal to m into x minus x1, that is equation number 1. Also we know that the slope of the perpendicular line, right? So the line joining the points x1 y1 and x2 y2. Suppose if you draw a line from x1 y1 to x2 y2, the slope of the line which is perpendicular to the line joining the point x1 y1 to x2 y2 is given by the formula. So reverse, right, minus reverse, right, reciprocal, or minus x2 minus x1 by y2 minus y1. Normally we know the slope of the point joining x1 y1 x2 y2, 2-point form of a slope, y2 minus y1 by x2 minus x1. But here the line perpendicular to the line joining x1 y1 and x2 y2, so the slope is minus the reciprocal of that one, that is y2 minus y1 by x2 minus x1, which is x2 minus x1 by y2 minus y1. We know, right, two perpendicular line, right? So product of the slope is minus 1. So m1 equal to minus 1 by m2, that is reciprocal of the second line, right? So m is the slope of one line, then the slope of the line which is perpendicular to the previous line, the first one, is minus 1 by m. That is the idea we are using here, right? To find the equation of the altitude AD, BE and CE, since AD is perpendicular to BC, so AD is perpendicular to the line joining the point B x2 y2 and C x3 y3. So slope of AD is using that formula, right? Minus x3 minus x2, x term difference by y term difference, that's all, right? So here x term difference x3 minus x2 by y term difference y3 minus y2 minus, right, and passes through the point x1 y1 AD. So equation of AD is y minus y1 equal to m into x minus x1 minus x3 minus x2 by y3 minus y2 into x minus x1. So cross multiplying, so y minus y1 into y3 minus y2 equal to minus x3 minus x2 into x minus x1. So we have to separate into x term, y term and constant term. So first to multiply y into, keep y3 minus y2 as it is, right, y into y3 minus y2 minus y1 into y3 minus y2. On the right hand side similarly x into, so bring that right hand side to the left hand side, so minus x3 minus x2 into x minus x1 becomes plus x3 minus x2 into x minus x1. Then separate now y into y3 minus y2 minus y1 into y3 minus y2. Then x term x3 minus, keep x3 minus x2 as it is, x3 minus x2 into x minus x3 minus x2 into x1 equal to 0. First to write the x term, x3 minus x2 into x plus y3 minus y2 into y minus y1 y3 minus y2 minus x1 x3 minus x2 equal to 0. So this is equation number 2. Next we need the equation of BE. Similarly replace in the cyclic order 1 2 3, right, suffix 1 to 2, 2 to 3, 3 to 1. Same. So if it is x3, then replace x1. If it is x2, then replace x3. If it is x1, then replace x2. Right? 1, 2, 3 in the cyclic order. So replace x3 by x1 minus x2 by x3 into x plus y3 instead of y3 put y1. 3, 1, right? y1 minus y3 into y minus y2 into y1 minus y3 minus x2 into x1 minus x3. That is equation number 3. And last, the equation of CF is replace the cyclic order, right? So x2 minus x1 into x plus y2 minus y1 into y minus y3 into y2 minus y1 minus x3 into x2 minus x1 equal to 0. Fourth equation. Now we need to prove these three lines are concurrent. 2, 3, 4. Right? For that we are using determinant idea, row reduction, diminishing row, right, method. So first write the coefficient of all the three equations, x coefficient, y coefficient, then constant term. So you will get the determinant. First x coefficient, first equation, that is second equation, x3 minus x2. Then its y coordinate, y3 minus y2, that is y coefficient. Then constant term, minus y1, y3 minus y2 minus x1 into x3 minus x2. Right? The same manner to for all the equations, right? Just like the first one, you write the coefficients of third one and fourth equation, right? So which is equal to, we are going to use row reduction idea. So first row can be replaced by row 1, first row plus second row plus third row, right? Adding all the three rows which is in the first row of the second matrix, equivalent matrix, right? Sorry, equivalent determinant, right? So that is R1 is replaced by R1 plus R2 plus R3. R2, R3 are as it is same like the previous one. So in R1, see, all the terms get cancelled, 0. Similarly, all the columns in the first row, right? So 0, 0, 0, right? So you will get the determinant like this. Then remaining R2 and R3 are same. In a matrix, if one row or column is completely 0, then value is 0 using that property. So this is 0. Therefore, this is concurrent. 2, 3, 4. That means altitudes are concurrent. So this altitude point of intersection of all the altitude is called orthocenter of the triangle. Thanks.